Hi everyone, JK here from SSW and welcome to the Full Stack User Group in Brisbane. And today I'm going to talk about the harmonious dance between EF Core and SQL Server. So what we're going to talk about is how can you use EF Core with some of the SQL Server features, and how does EF Core even generate some of the queries that you might be confused when you look for their logs and say, why does it do all of these things? So first off, I am Jernej Kavka from SSW, a solution architect. I'm an AI MVP. You can follow me on all of these socials, on GitHub, my blog, LinkedIn, hosting also Global AI, the podcast. And predominantly, I am a .NET and EF Core developer. And before we start, if you like to win some good rewards, you can download our SSW app to get some SSW points. And at the end, I'm going to give you another QR code where you can scan it, give us feedback, and potentially win some good prizes. I have done a similar talk previously at NDC conferences, as well as for SSW TV, about common mistakes in EF Core. And this is kind of a continuation of that, where I'm now adding SQL Server to the mix. All right, so the way we're going to go today is by first looking at the logs, telemetry, and tagging. And this is because I think that having good logs and understanding what's going on with your application is very important. And EF Core has some special things that you can do to actually have a better insights in your application, like performance of your queries, or what queries are failing, or what's happening in general with your application. Then we're going to move to the magic of joining tables. I'm going to show you a little bit how SQL Server represents data and how it merges different tables. And then I'm going to show you how EF Core does that. And at the end, I'm going to show you a little bit about indexing in SQL Server, how you can leverage that with EF Core, because what I see is that too few EF Core developers are using indexing in their application, and that actually impacts the performance in production quite a lot. So why is logging so important? Well, for me, one of the most important parts in logs is to figure out what happened. For instance, a web request crashed. So that's very important. Then the next part is when it happened. Like, for instance, was there a peak in that time and maybe the SQL Server timed out? Or maybe we just happened to have a period where a lot of managers were trying to create invoices. Why it happened? Well, it's a big difference if somebody tried to edit, for instance, an invoice that is logged opposed to an invoice that is not logged. So you should know why the exception happened. And lastly, where it happened. So where in the code can I find this issue so that I can try and fix it? And here is an example of a log in Application Insights. So what you can see here is the exception is the what. Then we have the event time, which is the when. We have the message, which is the why. The invoice was locked. And then we have the where, which is the exact location of the class and the method that failed at that time. So this gives me enough information to tackle the issue. Now, with SQL, it's similar thing. If we just see in a log and we don't know what query it is, we won't be able to action it much. And in order to fix all of those issues, to make our application well-versed in logging and tracing, we should start with telemetry. Specifically, we use Application Insights. If you're on .NET side, .NET 8 side, you have now open telemetry, which allows you to also link up with other services. And here I have added a link to the Application Insight setup, This one, I have just a URL here because depending on whether you have console application, WPF, Azure Web Application, Azure Functions, each might have a bit different way of how you set up the application insights, and it also changes a little bit over time. So best is to look up what is the most recent way of setting things up. Also, if you deploy to Azure, a lot of the things is done for you. And we also have rules to better application insights. So if you use application insights, this will help you a lot in not just setting up, but also what you can do extra things with application insights. And this is the difference when we configure everything in the application insights, specifically for SQL Server. By default, you might see something like down below command, where we just know what database got hit. But when we configure everything correctly, now we can actually see what is the SQL query, which can make big difference when you're trying to identify what is wrong with your application. The next part is .NET and EF core logging. And here, the simplest way to do this is in the .NET application, you can open the app settings.json and add Microsoft Entity Framework core as information in the logger. And this will now give you an additional logging in your console and wherever you also added your loggers to put the logs in. So if you configured application insights, these logs will be available as well. We also have rules about doing a better tracing. So if you're interested in more advanced setup, there's more information in there as well. And lastly, the most interesting part of here, which is not talked as much as I would want to, is how to add additional context about the SQL queries that we execute via the code we write. So here we have the EF core tag width, which actually existed since EF core 2.2. And what this one does, we can call this method and add some additional string, which is going to add to the SQL query. Now, this is going to be visible even in SQL Profiler. It's going to be visible in the application insights. However, there might be some tools that will strip out the comments. Most of the tools that we are using luckily don't strip it out, but I heard from some people that it does strip out. And we also have some rules about that as well. And you might be looking at this and say, well, I don't want to manually identify each individual query. This is why Microsoft added tag width call side from EF core 6, which what it allows you to do is instead of you needing to write manually where that file is and the line of that query, it generates it for you. Now, personally, I don't like this. It's just too much text. The line numbers constantly change from one version to another. So if you see this in the log and then you look at the line 85 and then you see there's no query over there. So your query might be 10 lines up, might be 10 lines down. I don't particularly like this approach. What I prefer is using my own custom tag width. And the good part is if you prefer different data, you can create your own. But here is what I do. For me, the most important information is the class name, the function, and what is the purpose of the query. So what I do is I tag with context and I put in purpose. The purpose is optional because if there's only one query in that method, I don't need to add additional information. There's just one query over there. And the method name might already give me the purpose of that query. And here what we get is we get a comment in the seq where we have the class name, which is examples count controller. We have the method, which is the best case. and then we have the purpose, which is counting sales. Makes it very clear from where it's coming from and what's the purpose of that query. And for anyone interested, this is the code. It's not that difficult. It leverages tag width, and it just sanitizes the class name, because we only are able to get automatically the file path, not the class name. So here we just simplify all of that, and down below is also the link where that code will be available. All right, so here we have different stages of logging. But what does that give us? I have shown you what you can do to improve the logs, but how does these logs look like once they're improved? Well, here we have lots of SQL requests. And by default, you click through them and you'll see nothing. You'll just say, okay, these logs exist. We don't know what they do. And what's even worse, this is saving timesheets, which has a branching logic. So there could be different queries depending on different conditions. So you cannot just say, okay, there are 11 queries, so this is what's probably happening. So this is where it's really good to have all of those stages implemented, because now we know what's happening. This is a SQL query. We know when it's happened. And most importantly, we know where and why it happened. It happened on the saved timesheets, and it checked if the employer exists. Now, yes, you can check the SQL statement, but once you try to diagnose what a 300-line long SQL statement does, you might appreciate to just be able to look at that comment and say, that's what it's doing. And what's even better is now we can just look at the logs and say, here, this log happened at 9:23. This is the comment, and it took me less than a minute to find the exact code where that happened. And then the next one, and the next one. And I can now spend less than a minute finding the exact line of code that this comment is referring to. Now, you could do that with just doing regular logs, but the problem is sometimes what happens is you're just getting not logs, but performance information about the queries that ran. And over there, comment is the only thing you'll get. You won't be getting from where it's been called. You won't be getting what's the context around that query. You're just going to get that raw SQL, and that comment will point you exactly to the code where you ran it. So that's what happens when you configure your logs well, and you get some more telemetry from your SQL, and you'll be able to diagnose and fix your SQL queries much easier. Now, the next one that I picked for this talk, because I actually had like 10 topics I wanted to cover, and then figure out it's going to take 4 hours. So I had to cherry pick, and this is the next one I cherry picked, is the magic of joining tables. Because there are a few things that a lot of people, they're either not aware that's happening, or it's in the back of their mind, but they never actually put any thought into it. And I want to put this forward. And what I'm talking about is, if we look first from the SQL Server perspective, how is SQL Server representing the data? Now, everyone is well aware, hopefully, that the data in SQL Server, when you request it, is flat. So if we request an author, we get a flat table back. Simple, right? But what if we join? It's still flat. And what's interesting over here is, see here we have duplicate William Shakespeare's for the author. Interesting, right? Now, you probably already know that, but do you actually think about what that means? Well, if we add tags to the mix, which is another table, that means that the William Shakespeare is now 5 times, because we have 2 blog posts that link to 5 tags. And now things are getting interesting. What if this content is like, I don't know, 500 kilobytes? That means that for this one blog post, we are downloading extra 1 megabyte for no good reason. So this is a good thing to know, because sometimes you have an issue where you're just downloading a massive amount of data from SQL Server because you're trying to join lots of tables that are one to many. And I'm going to show you in EF Core a little bit later how you can address that when that problem occurs. But what you can do if you happen to hit this problem is, well, in most of the cases, the transfer rates between the SQL Server and the application is fast enough that that's actually not the problem. Also, EF Core is fast enough that it just skips all of the authors that are duplicated, and it has almost no performance implications if the infrastructure is well made. SQL Server and EF Core applications are very close by. And also another thing, databases can stream data really, really quickly. But that doesn't mean that it's not a problem if you have columns that are really large and you're starting to have lots of redundant rows. That could be a problem. And writing queries to basically combat this can be quite annoying, because what now you need to do is you need to fetch data separately, and then you need to also write in .NET, for instance, a code that then merges all of that data back together. So it can be a lot of work if you want to reduce that redundancy. And if you ever find that you might have problems, we have some additional advices for you to look at and diagnose some performance issues specifically on your SQL Server. But what I want to now focus on is EF Core. So what EF Core does is, when we're getting data from SQL Server, it's a flat table. But what happens once EF Core passes all of the data and puts into memory, it's more like a list of graphs. So we have no duplications because EF Core can represent that data in such a way that we don't need any duplications. It's represented completely differently, which is why sometimes you have the issue when people look at group by in SQL and group by in .NET. They're actually not identical. And let's look at how we generate SQL queries in EF Core. So here I have a very simple query on authors, where we just filtered by one author, and we fetch only one author. There's nothing too special over here. The only thing here to emphasize is, if you have never seen how the selected author would be pushed into that SQL query, this is how. Usually in EF Core, the parameters are done with @ and then __. And it tries to preserve the original name. If the name does not exist, it does @0, @p0, @p1, and increments the parameters. Now, if we try to merge, join additional table, here I'm using implicit join with over here with the posts. Because EF Core just allows me to use tables that are linked to the author and directly select all of the data. You can see that we have just a simple left join, fetches all of the data, and then on top select, we are selecting all of that post data. But what you might be surprised is the author table. We don't just have from author the table. We actually have a from, and inside of it we have a select statement. So what EF Core does here is it tries to reduce the size, the amount of columns the table will have and the amount of rows it will have before joining with the post table, and essentially pre-filtering all of the data and columns before joining. But what becomes even more interesting is when we're adding tags. Now, what happens here is a pretty big query for all things considered. And you might be questioning yourself, what is going on here? Like, why there's a lot of SQL over here? And what it turns out is, first off, this is a link table between posts and tags. So that adds a little bit of additional query. But another thing that is happening is it does a similar logic as before with authors. It tries to make the table as small as possible with as few as possible data before it joins with the author. Essentially, what that means is, in a way, EF Core tries to make as consistent as possible query generation. So if you look at here, this is somewhat consistent with the query above, where we are trying to pre-select all of the data. But on the other hand, it also tries to optimize for data scale. So if you have millions of authors or millions of posts, this query can generate better performance. And another thing here is, if you have, for instance, 10 joins, rule of thumb, especially if you started doing wave filters, group bys, and havings, and things like that, EF Core will probably generate a code that is more accurate than yours. It might not be as performant as yours, but it's likely going to have less bugs. But the downsides of this is that it's not always easy to read. So it may generate a lot more SQL queries than what you would be used to by a handcrafted human SQL code. And also doesn't always do the most optimal code, but generally speaking, it does a pretty optimal code for what it tries to do. All right, now let's go back to data redundancy. Do you remember this part over here? So we have a couple of duplicated authors, we have a couple of duplicated posts. Can we fix that with EF Core simply? Well, it turns out we can use query splitting. And it's literally just one line. And the result of this one line is that it splits up this one query into 3 different queries. And these queries are optimized for only fetching the data from those tables. So you don't get any data redundancies. Now, in some cases, these queries can run a lot faster than the bigger ones, because you might have memory constraints. This may actually reduce the amount of data it has to deal with, and depending on your SQL Server configuration, may actually result in better performance. We actually had a leaderboard just, I think, 4 weeks ago, where doing something like this speed up the performance by 100 times. But rule of thumb, usually it's going to be similar performance or slightly worse. But you do not get any data redundancy, and in some cases, you can get huge performance boosts. Also, for eagle eyes, you might notice that these queries inside of there, they're not quite necessary because we already know the author's ID, and we can already use it directly in the post table, so we could skip one join. Generally speaking, the SQL Server does a pretty good job to optimize this kind of cases so that you don't have to tweak these queries manually. So it's not too big of an issue. So what query splitting allows us to do is basically split all of these queries with just one line of code. And we don't need to write a logic on how to merge all of that data back together. That's done for us. In some of the cases, it can do drastic performance improvements. We had one case where we just didn't have enough memory to process all of that data, and the performance improvements were insane. And there are also cases where you're just trying to fetch too much data through the wire, and this can help. It does a really good job at splitting the queries. And this is one of these caveats. It's not a silver bullet. So what you want is to write a query, fetch all of the data, try to use the split query, and see how they perform. It may work better, it may not. And there's a lot of dependencies on how close the SQL Server and .NET 8 application is, on lots of infrastructure, whether it's on-prem, is it on cloud, and the scale of the data. All right. Now we went through how we can look at joining tables in SQL Server and EF Core. Now we're moving to my favorite part, is the indexing. And the reason for that is this is a very underused feature with EF Core developers. They know they should be using indexes. They might see reports in SQL servers and Azure SQL servers to do the indexes, but I rarely see them in production codes. And I hope that with this, I'm going to fix that a little bit to make developers a little bit more comfortable using indexes. I'm not going to go too into details. We have Bryden over there who done an amazing job on how to make really performant database, but I'm just going to go very high level on the indexes. So why you want to have indexes? Generally because performance. Now, what kind of indexes do you have on SQL Server? Now here I have selected two indexes. The ones that you most commonly will see is the clustered index, which is only one per table and basically defines how your data is going to be stored physically on the disk. And by default, EF Core uses that on your primary keys, which would be your ID. Now, we're not going to specifically focus on clustered indexes today. We're going to focus more on the unclustered indexes because these ones are more interesting because you can have multiple of them in a single table. And the way unclustered indexes work is you can almost imagine is it creates another table with the columns that you have selected, and it's sorted with the same it's sorted in the same way as the clustered index, which can then help to map things together. I have seen that some of the features now support ordering. That's something I'll need to play around with Bryden. But today we're going to just focus on simple unclustered indexes. And how can you see which indexes are we using when we're doing specific queries? Well, in Azure Data Studio, we have here the button Enable Actual Plan. And when you enable this and run a SQL query, what we get here is the query plan. And over here is, you can see from which index SQL Server will use to fetch all of the data. Now, how do we add indexes in EF Core? Well, when we are in DB context, we create a on model creating if you don't have one. And here we just simply define the entity and what indexes we want. In this case, I selected country because maybe we want to, we have a query where we often filter authors by country. Imagine that we're having something like Amazon or Audible, and we want to get all of the authors from a specific country because of licensing. And such an index would make sense to do because it will allow you to fetch authors a bit faster when you filter by countries. And here you can see that when I'm doing select country from author, it is not using the PK author, which is the primary index. It's actually using IX author country, which is being created by that EFCO code. Now there's a bit of a caveat here, because what if we add the name, the author's name, right? That would make sense to add into such a query. Well, what you might see is the rectangle is a little bit too high, but below the rectangle, you can see that it's actually selecting the primary index, the PK author, which is not the key that we created, not the index that we had created. But we can fix that. And we can fix that by specifying to EF core that we should include the name in this index. Now here, what we're doing is we're not indexing name. We are just saying, hey, with this index, include this data. That has some performance implication for good and bad. And now if we run the same query, we can see that we now run the, use the index IX author country. So we're using that more optimized query. But what you can also do is you can do a composite index. So we can use country and name, and that allows us to do more complex queries with filtering and ordering with this.
How many more when we might suit?
So the question is, how many more can we add to indexes? I believe Bryden would be the best person to answer that.
Generally as many as white, but there are optimum boundaries, size of the row.
Yeah, to repeat the answer, you can add as many as you like, which is what I thought. Yeah, but you get diminishing returns, so there's you should be testing how much. You probably wouldn't want to go too big. There was. Sorry? Oh, okay. We have more precise answer. Up to 900 bytes. That's correct. All right. So now that we have the composite key. Sorry, not composite key, a composite index. What we can see here, we're doing select name, country from author, and this looks like the same index, but if you notice, it's author, country, name. Before, it didn't have the name in it because it just included the name into the index, but it wasn't using it for indexing. And yeah, that's how we set up indexes. The only thing that I would add here is you can add multiple indexes for the same table. You can add as many different indexes as you like, as long as they're unclustered. And you definitely should check out Bryden's talk about the details on when is too far when you start and create multiple indexes.
You
can only have one clustered index and as many unclustered indexes as you like.
And this the model different. It's not that it.
Apologies, can you say that again? Yes.
Fraction.
Okay. So the question is, this is just a model builder. So here in this model builder, we actually generate the database schema. So here we are defining database schema, and the great thing about code first approach is that for developers, I can look the references to the author, for instance, or references to the country, and I can see in my code that this is being used as an index. So I know as a developer, I don't need to look up at the database schema to check what indexes I have. I have that available in my code. Does that answer your question? All right. Now you might be wondering, well, that's all awesome. I can now create indexes. How do I know what indexes to create? That is a very good question, and this is something that has been historically been quite a bit of a challenge. Now you can use the Azure portal, the Azure SQL Server performance recommendation to see what recommendation it has regarding the indexes. My database people say that take that with a huge pinch of salt, but at least might put you in the right direction, saying, oh wait, this table has a lot of recommendation for indexes. I definitely need to look into this and see what would be a good index. If your table is not on the list, you probably don't need an index for it. And if you're not on Azure, here is a SQL statement that you can run to get similar data as on Azure. And down below is the link where you can also copy the code and have a lot more information about how do you actually identify what are the SQL Server issues. And with that, what I hope is that I can bring the EF Core developers a little bit closer to SQL Server, to SQL queries, and better understand what is going on behind the scenes and be a little bit less afraid of creating indexes, a little bit less afraid of looking at what EF Core is generating, as well as not just blame EF Core, it just doesn't generate good queries, but actually look at the queries and see what's going on, because you might actually be surprised at the things you might find. You can copy paste it, for instance, into ChatGPT and ask it, hey, what does this query do? And is this query performant? And the answers, they sometimes are surprising. You're like, I never knew you should be doing that for, if you have lots of data. For me, it's just like unnecessary select statements, but apparently it does make things faster. And what is even more interesting is you have now JSON support in EF Core 8. So you might see some changes from your existing queries moving to EF Core 8. And yeah, going through those queries, I was very surprised with some of them. It literally used JSON to convert an array into the input was a string as an array, and then in where clause, it deserialized it as a JSON array, so that you didn't have to put each individual parameter into the SQL query, but it could just put one parameter as a string of array that can be deserialized. Here I have lots of resources for people live. You can take a picture later. And with that, thank you.
We've got a couple of questions from the studio audience and online. So the first one was, you said indexing can improve performance and sometimes it can diminish it. It seems pretty clear how it could improve it. How does it make it worse?
Now, this is where you can correct me if I have the right picture of it. But what I imagine is if you create too many indexes, they are literally almost like copies of your table from the columns that you select. And if you have too many of them, your updates, your inserts, your deletes can get much slower. And also SQL Server has to take a little bit more time to figure out which one to use. But that's
spot on. Yeah, it's when it comes to updating, it's much worse, potentially. And the other one we saw was, you said you could join 10 tables. Do you really think that's a good idea?
I never said it's a good idea. We had a few clients where we said, this is a terrible idea, we shouldn't be doing. And then after 2 days, I guess we're doing this. We literally just didn't know how to do it better because the DB schema was, how to use a nice word. You have to have a specific taste to like it. It was super complicated.
So would you use that feature that you called out here, the split query feature for that now?
Actually, now that you mention, back then we didn't have that feature. Well, we did have, but it didn't work well. With EF Core 8, I was genuinely surprised by some of the split queries. I could probably write it better manually, but considering how much code I would need to merge all of that data, I was just like, I'm happy with it. It probably saved me a couple of days. So the short answer is probably yeah.
Yep. So it was great hearing from you, JK. Thank you very much.
Mm-hmm. Yeah, and I hope this presentation will bring database and developers a bit closer together, not be on non-speak terms.